All right, so we are on the review for Unit 10. We are figuring out the area of the triangles. So on this next one, it's number 7. We, of course, have this formula for area of triangles, and we need an angle. We need angle C for that. So angle C just needs to be between two known sides, and we have all the sides known. So we're going to have to use the law of cosines to come up with an angle measure first, unfortunately. So we'll pick a side and pick an angle for the law of cosine. So I'm going to pick 17, and then the angle across it is what we'll look for, or is what we'll find. So 17 squared is equal to the square of the sides, 10 squared plus 23 squared, minus 2 times 10 times 23 times the cosine of x degrees. Okay. And then again, just like before, we need to now solve. So we'll subtract 10 squared and 23 squared from both sides. So that ends up being 17 squared minus 10 squared minus 23 squared is negative 2 times 10 times 23 cosine x. And we are trying to solve for cosine x, so we're going to divide by this negative 20 times 23. And I just know negative 2 times 10 is negative 20, so, and I want to conserve space. So we'll just multiply by negative 20 times 23, and we're left with cosine x, so cosine inverse of 17 squared minus 10 squared minus 23 squared all over negative 20 times 23. And we're going to plug that in the calculator. Let's see, so we need cosine inverse second cosine, come up with the fraction, 17 squared minus 10 squared minus 23 squared, and then arrow down, negative 20 times 23, arrow out, finish off your parenthesis, and we get the angle there is 42.34 degrees. All right, now we have everything we need to come up with the area using our formula 1/2 AB sine C. So our area is going to be, I'm just going to write sine of that, sine of that angle, and build it from the left. So 1/2 times A times B. Now we have this angle here. So we have to use, I'm going to make them yellow, this side and this side. So remember, it's the two sides that wrap the angle that we know, the known angle. So we're going to have to take 10 and 23 and multiply them by the sine of that 42.34 angle, because that is the wrapped angle. All right, so 0.5 times 10 times 23 times the sine of, now I'm just going to go up and extract it to get the most accurate area, and it's 77.460 square feet. All right, so quite a bit of steps here. First, we had to figure out that angle using that. Okay, figured out the angle first. And then second, we put that angle into our area for a triangle and find the area. All right, let's see. The distances from a boat to two buoys are 75 meters and 52 meters. So we have our boat, and we have two buoys that are in the water. So from the boat, we have one distance that's 75 meters, and we have another one that's 52 meters. If the angle between the two lines of sight is 67 degrees, so this angle right here is 67 degrees, then find the distance between the buoys. So we want this distance, round to the nearest tenth of a meter. All right, so looks like we are going to have to use the law of cosines, right? Because we don't have a side and an angle opposite it. Oh, well. So x is equal to the square root of 75 squared plus 52 squared minus 2 times 75 times 52 times the cosine of 67 degrees. All right, placing that in the calculator, and you guys can also, along with me, see if we all get the same answer. Hopefully we do. Minus 2 times 75 times 52, cosine 67. All right, so I got 72.673, but it wants to the nearest tenth. So 72.7 meters is how far apart the buoys are, which is a really cool thing to figure out while you're in a boat, in case you want to know how far apart the buoys are, and you know the other measures, the measures between you and the buoy. Cool. All right, next up. Let's see, where's my, come on. Okay, Jack and Jill are 9 miles apart on level ground. So here's Jack. Here's Jill. Oh, she better have a longer dress than that. All right. There's Jack and Jill, and they are 9 miles apart. On level ground, Jack can see a hot air balloon at an angle of 27 degrees of elevation. So here's their hot air balloon. So 45 degrees. And, Jack's was 27. Sorry, 27. Dun, dun, dun. Gosh, that's like crazy. Okay, so he's 27 degrees. Jill can see the same hot air balloon at an angle of 45 degrees. And the hot air balloon is between Jack and Jill. Find the distance between the balloon and Jack and the balloon and Jill. So we want this and this distance. We want to know the distance between the balloon and both people. Well, that's okay because we can use law of sines and cosines because we have 2 of the 3 angles. So our law of sines, which is awesome. So 180 minus 27 plus 45 to get that other angle. And that is 108 degrees. All right, and so we know 9 miles is across from that. So the sine of 108 degrees over what's opposite 9 miles is equal to, let's do x first. So sine of 45 over x. And this is what we're looking for first, right? All right, so we do x times the sine of 108 is equal to 9 times the sine of 45. And divide by the sine of 108, which is just a number. We don't have to worry because it has s's and i's and n's in it. So x is equal to 9 sine 45 over sine 108. Equals 1. So make yourself a fraction. 9 sine 45 over sine 108 is going to be approximately 6.691 meters or miles. All right. Then we'll find, this is Jack. Now we'll find Jill's distance. So we're going to use the same sine 108 over 9 because that's our ratio that's known. And let's see, Jill is 27, so sine 27 over z. All right, so Jack had to find the angle measure to the balloon, his angle measure, in order for Jill to use to find the distance between her and the balloon. Pretty cool. Okay, z times the sine of 108 degrees is equal to 9 times the sine of 27 degrees. So we'll divide by the sine of 108. And that gives us z is equal to that, 9 sine 27 over sine 108. So I'm just going to extract it. 9 sine 27 over sine 108. All you had to do is change the angle 45 to 27. So it's approximately 4.296 miles apart. So from Jack, about 6.691 miles, and from Jill, about 4.296 miles. So it's closer to Jill, isn't it? All right, so that's the whole review. Good luck with the review. I'll have the test up soon. Good luck. If you have any questions, contact me. Come to our meetings, our Zoom meetings. We can go over anything you need to before the test. It's not Zoom, sorry, it's Google Meet. Have a good day.